Hello, my dear students. Please subscribe our YouTube channel for more free video lectures and click on bell button for notifications and visit our website to purchase full course.
Welcome back to another session of Strength of Materials. In this session, we are going to deal principal stresses, principal planes. So first we derive the formula for principal planes, formula for principal stresses. Thereafter, we are going to derive a formula for maximum shear and a formula for shear planes. In this way, we move, right? So first let us try to derive a formula for major principal stress and minor principal stress. In last session, I told the highest normal stress is called major principal stress, lowest normal stress is called minor principal stress. Highest normal stress is called major principal stress, lowest normal stress is called minor principal stress. So, first I am writing normal stress equation. Normal stress sigma n is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos 2 theta plus tau xy sin 2 theta. So this is the formula to find normal stress on any plane. Now the highest sigma n is called major principal stress, lowest sigma n is called minor principal stress. To find highest value or lowest value of a function, what to do? We differentiate the function and we equate the differential to 0. From that we get one condition. On putting that condition in original function, we may expect highest value or lowest value. So to find highest value or lowest value of sigma n, we have to differentiate. So here we are differentiating. We are differentiating sigma n with theta, right? D sigma n by d theta is equal to differential of sigma x plus sigma y by 2. Sigma x, sigma y are loads, sectional loads. So they are 0, they are constant. Differential of constant are zeros, right? These are not function of theta, right? So they are loads, given loads, right? They don't change with theta, right? So differential of sigma x plus sigma y by 2 is 0 and differential of sigma x minus sigma y by 2 into differential of cos 2 theta sin 2 theta minus sin 2 theta and the differential of 2 theta is 2 plus tau xy into differential of sin 2 theta is cos 2 theta and the differential of 2 theta is 2. Okay, so here we differentiated normal stress formula, right? Normal stress with theta. Here we are trying to find highest sigma n and lowest sigma n. So at highest value and lowest value of sigma n, its differential will be 0. Highest value or lowest value of function, its differential will be 0. So this is equal to 0. On rewriting this equation, I get something like this. Tan 2 theta is equal to tau xy by sigma x minus sigma y by 2. So tan 2 theta is equal to, okay, you can cancel this 2 and this 2 and bring all sine quantities to one side, bring all cos quantity to sine side, sine by cos tan. So finally, on simplifying this, we get tan 2 theta is equal to tau xy by sigma x minus sigma y by 2. So when tan 2 theta is equal to this much, sigma n will be either highest or lowest. That means what? When tan 2 theta is equal to this much, sigma n will be either highest or lowest. Which planes carry highest normal stress and lowest normal stress? In previous sessions I dictated. The plane which carries highest normal stress is called major principal plane. The plane which carries lowest normal stress is called minor principal plane. So indirectly this theta indicates what? Angle of principal planes, right? So that is why I am putting P here, right? P here. Here theta P indicates angular principal planes. Theta P indicates angular principal planes. Okay, this is one of the important formulae. So don't forget this. Few gate problems came on this formula, right? By using this formula, you can find angle of both the principal planes, right? Major principal plane and minor principal plane. Please copy these two steps. So copy these two steps. From these two steps, we derived a formula to find angle of major principal plane and angle of minor principal plane. So up to this point, you may copy. I hope you copied. Okay. I can write tan 2 theta p like this also. Tan 2 theta p is also equal to tan 180 plus 2 theta p. Tan value doesn't change. When angle is 2 theta p or 180 plus 2 theta p, we all know tan 180 plus 2 theta p is again tan 2 theta p. So what is the meaning of this, man? Right? Tan value is same for either 2 theta p or 180 plus 2 theta p. That means what? There are two angles, man. There are two angles which may satisfy this equation because tan 2 theta p is also equal to tan 180 plus 2 theta p. So there are two angles which may satisfy this equation. Two angles means what? There are two planes, right? One plane is major principal plane, other plane is minor principal plane. Please copy this. Please copy this and write down this statement. So tan 2 theta p is equal to tan 180 plus 2 theta p. Then you may write this statement. The above expression shows there are two principal planes. The above expression shows there are two principal planes which are separated by. There are two principal planes which are separated by how much angle? What is phase difference between 2 theta p 180 plus 2 theta p? Phase difference is 180. For 2 theta p, phase difference is 180. What is phase difference for theta p? For 2 theta p, 180. For theta p, 90 degrees. So this equation is saying there are two principal planes. Angle between those two principal planes is 90 degrees. Understand? Now continue our statement, man. Which are separated by 90 degrees. Which are separated by 90 degrees. 90 degrees in bracket. Principal planes are orthogonal. Principal planes are orthogonal. Principal planes are orthogonal. Principal planes are orthogonal. Orthogonal means mutually perpendicular. Okay, this is one point. Then from this tan 2 theta p is equal to tau xy by sigma x minus sigma y by 2. I am going to construct a triangle. A triangle I am going to construct a right angle triangle. This angle is 2 theta p. This angle is 2 theta p. Now, what is tan? Tan means opposite side by adjacent side. Tan means opposite side by adjacent side. What is opposite side? Tau xy. So I am putting tau xy here. What is adjacent side? Sigma x minus sigma y by 2. Then what will happen to hypotenuse or diagonal? From Pythagoras theorem, we can write diagonal is equal to square root of sigma x minus sigma y whole square, of course by 2 is there, plus tau square xy. So please copy this triangle. From this equation, we have drawn one right angle triangle, right? So draw the triangle. This is called principal plane triangle. Principal plane triangle, because I have drawn the triangle from this equation only. Okay, this is called principal plane triangle. So please copy this triangle. Please copy this triangle. I have drawn the triangle only from this equation. Only from this equation, okay? Of course, if you simplify this, you get something like this, man, right? If you simplify this, you may get something like this: 1 by 2 into square root of sigma x minus sigma y whole square plus 4 tau square xy. Earlier and this is same, so don't worry, man, right? Now, from the triangle, you tell me what is cos 2 theta p? Cos 2 theta p equal to adjacent side by hypotenuse. That means half into square root of sigma x minus sigma y whole square plus 4 tau square xy. Similarly, let us write sin 2 theta p. So sin 2 theta p means opposite side by hypotenuse, that is half into square root of sigma x minus sigma y whole square plus 4 tau square xy. So from this triangle we can write this too. Simply cos means adjacent side by hypotenuse, sin means opposite side by hypotenuse. Please copy these two. By observing this triangle, we wrote these two. I hope you copied. Right. So now let us try to put this cos 2 theta p and sin 2 theta p values in this expression. If I put theta p here, what I will get? Theta p indicates angle of principal plane. Theta p indicates principal plane. If I put theta p here, I get normal stress on principal plane. Normal stress on principal plane. Normal stress on principal plane is nothing but principal stress. On first principal plane, you will get normal stress, that is called major principal stress. On second principal plane, you get another normal stress, that is called minor principal stress. So here I replaced theta with theta p. Automatically I am going to find normal stress on first principal plane. Normal stress on first principal plane is nothing but the major principal stress or first principal stress. Okay, normal stress on principal plane is principal stress. So here I replaced theta with theta p. So automatically we find normal stress on first principal plane, that is nothing but first principal stress. We know what is cos 2 theta p. What is cos 2 theta p? Just I wrote cos 2 theta p means sigma x minus sigma y by 2 by this. We know sin 2 theta p, tau x y by this much. So let us write it. So sigma 1 is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into sigma x minus sigma y by 2 by half into square root of sigma x minus sigma y whole square plus 4 tau square xy plus tau xy into, and what is sin 2 theta p? Tau xy by this entire thing that means half into square root of sigma x minus sigma y square plus 4 tau square xy. If you simplify this, you get something like this. Sigma 1 is equal to sigma x plus sigma y by 2 plus half into square root of sigma x minus sigma y whole square plus 4 tau square xy. So here sigma x minus sigma y is there. Here also sigma x minus sigma y is there. If you multiply these two, you will get sigma x minus sigma y whole square. Here tau xy is there. Here also tau xy is there. Tau xy into tau xy, tau square xy. Okay. So I'm simplifying this here. You can add this sigma x minus sigma y whole square plus tau square xy. Then automatically the square root will come to numerator. It's very real simple simplification. So finally you get sigma 1 is equal to this much. This is the formula to find major principal stress. Major principal stress can be found by using this formula, sigma x plus sigma y by 2 plus half into square root of sigma x minus sigma y whole square plus 4 tau square xy. Okay. So this is the formula for major principal stress or first principal stress. How to find formula for minor principal stress? We know angle between two principal planes is 90 degrees. If the angle of first principal plane is theta p, what is angle of second principal plane? 90 plus theta p. So for our reference I am writing here angle of major principal plane is equal to theta p, then angle of angle of minor principal plane will be 90 plus theta p, because angle between two principal planes is 90. Principal planes are orthogonal, we know this. Okay, so please copy up to this. So first you copy these three steps: first step, second step, third step. After writing these three steps, you may copy these two. Okay, first you copy these first, second, third, then you may copy this, right? Here theta p indicates principal plane. When you put theta is equal to theta p, you are finding normal stress on principal plane. Normal stress on principal plane is called principal stress. Like that you have to understand. Okay? So write down these three steps. Then you can copy this. This is the formula for major principal stress. We need to memorize this formula. Of course, every formula you have to memorize. Especially this formula is important. I hope you copied this. Now you copy this. If angle of major principal plane is theta p, the angle of minor principal plane should be 90 plus theta p, because angle between two principal planes is 90 degrees. Okay? So angle of major principal plane theta p, automatically angle of minor principal plane will be 90 plus theta p, 90 degrees actually, right? If you measure theta in degrees, so 90 degrees plus theta p. Okay? Let us try to find theta 2, man, right? Let us try to find theta p. Theta 2 actually, right? The minor principal stress sigma 2 is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos 2 into what is angle of minor principal plane? Angle of minor principal plane is 90 plus theta p. Okay? So 90 plus theta p plus tau xy into sine 2 into 90 plus theta p. Okay? Now what happens? Sigma 2 is equal to sigma x plus sigma y by 2. Here 2 into 90, 180. 2 into theta p, 2 theta p. So this expression becomes, cos 180 plus 2 theta p. What is cos 180 plus 2 theta p? Minus cos 2 theta p. So here I get minus sigma x minus sigma y by 2 into cos 2 theta p. Again here 2 into 90, 180. 2 into theta p, 2 theta p. So sine 2 into 90 plus theta p becomes sine 180 plus 2 theta p. What is sine 180 plus 2 theta p? Minus sine 2 theta p. So here also I will get negative sign. Minus tau xy sine 2 theta p. In the expression of sigma 1, here we got positive, here we got positive. In expression of sigma 2, both are becoming negative. And we know what is cos 2 theta p, we know what is sine 2 theta p. From principal plane triangle, we can read what is cos 2 theta p, what is sine 2 theta p. If you simplify this, You will get formula for sigma 2. Sigma 2 is equal to sigma x plus sigma y by 2 plus half into square root of sigma x minus sigma y whole square plus 4 tau square xy. If you simplify, automatically you will get this one, right? So this is the formula for minor principal stress. Please copy. So this is the formula for sigma 2. I hope you copied. So just now we derived a formula for sigma 1, another formula for sigma 2, right? We know sigma 1 formula, we know sigma 2 formula. Both formulae are available. Right? Now we can examine a particular thing. Somebody may calculate what is sigma 1 plus sigma 2. We know sigma 1 formula, we know sigma 2 formula. You add sigma 1 and sigma 2. In sigma 1 formula, sorry, this is minus here. I am very sorry, man. Please correct. Here minus will come. Okay. Please correct it. For sigma 1, here plus is there. For sigma 2, here minus is there. When you add sigma 1 and sigma 2, second part will cancel each other. Only first part will be there. Sigma x plus sigma y by 2 plus again sigma x plus sigma y by 2. That means sigma x plus sigma y. Never forget this one. Always sum of principal stresses will be equal to sigma x plus sigma y. In previous session we observed sum of any two mutually perpendicular normal stresses is always constant, which is always equal to sigma x plus sigma y. Sigma 1, sigma 2 are also two mutually perpendicular normal stresses. Their sum also should be equal to sigma x plus sigma y. We proved also, man, right? So never forget this. In some problems, they'll give sigma x, sigma y, tau xy. They may ask you to find sigma 1 and sigma 2. Find sigma 1 and sigma 2. Then verify whether sigma 1 plus sigma 2 is equal to sigma x plus sigma y or not. If they are equal, your answers will be correct. If they are not equal, your answers are wrong. Always sigma 1 plus sigma 2 will be equal to sigma x plus sigma y. Never forget this, man. Okay? Right. Let us examine one more point here. One more point. Write it, man. Shear stress on principal plane. Shear stress on principal plane. Shear stress on principal plane. So the formula for shearing stress is, first write shear stress on principal plane. A side heading, shear stress on principal plane. The general formula for shear stress is minus of sigma x minus sigma y by 2 into sine 2 theta plus tau xy cos 2 theta. This is the general formula to find shear on any plane. I want to find shear stress on principal plane. So what to do, man? In place of theta, I have to put P here. I have to put P here, right? Theta P indicates principal planes. So what this expression gives you? this expression gives you shear stress on principal plane. You know what is sine 2 theta p? What is sine 2 theta p, man? From principal plane triangle, you can easily write sine 2 theta p is equal to tau xy by sigma, just wait, tau xy by half into square root of sigma x minus sigma y whole square plus 4 tau square xy. Similarly, we know cos 2 theta p. So cos 2 theta p is equal to sigma x minus sigma y by 2 by half into square root of sigma x minus sigma y whole square plus 4 tau square xy. Okay, 4 tau square xy. From principal plane triangle, I can read these two. On putting these two in this expression, you will get a big zero, man. You can easily verify. First write this, then copy this. Sin 2 theta p is equal to this much, cos 2 theta p is equal to this much. On putting these two in this expression, you will understand shearing stress on principal plane is 0. Please copy. First you copy these two steps, and maybe in right of your notebook you may write this. Sin 2 theta p is equal to this much, cos 2 theta p is equal to this much. So you may first copy these two steps, then you may copy these, right? So we understand principal planes don't carry any shear. Principal planes don't carry any shear, okay? So copy this step, then put 0. Then for our reference, if you want to write this two, you can write, okay? You can write. Okay. Now write one point here. Principal planes don't carry any shear. Principal planes don't carry any shear. Principal planes don't carry any shear. Like that you write. Principal planes don't carry any shear. Okay. Let's move to second part of this session, right? You may write maximum in plane shear stress and shear planes maximum in plane shear stress and shear planes. This is our second part of this session. In first part, we derived formula for major principal stress, minor principal stress. We derived formula for principal planes also, and we proved principal planes don't carry any shear. In second part, we are going to deal on shear, right? So maximum in plane shear stress and shear planes. Please copy this. Maximum in plane shear stress and shear planes Right. The general formula for shear stress is minus of sigma x minus sigma y by 2 into sin 2 theta plus tau xy into cos 2 theta. This is the general formula to find shear on any plane. It's a general formula. Now I want to find maximum tau n. What is maximum value of tau n? What to do? Either to find maximum value or minimum value, we have to differentiate the function and we have to equate that function to 0. From that you will get one condition. On putting that condition in original expression, you will find maximum and minimum values. So to find maximum value of tau n, I have to differentiate. d tau n by d theta is equal to sigma x minus sigma y by 2 Differential of sine 2 theta is cos 2 theta. Differential of 2 theta is 2 plus tau xy into differential of cos 2 theta is minus sine 2 theta, and the differential of 2 theta is 2. At highest value of tau n, its differential should be 0. From this expression, I can write tan 2 theta is equal to minus of sigma x minus sigma y by 2 by tau xy. On simplifying this, bring sine quantities to one side, then bring cos to that sine side, sine by cos tan, right like that, man. So we get like this, tan 2 theta is equal to minus of sigma x minus sigma y by 2 by tau xy. So when tan 2 theta is equal to this much, tau n will be highest. When tan 2 theta is equal to this much, tau n will be highest. That is the meaning, man. So that means I have to put S here. S means what? Shear plane. So theta S indicates shear plane. In previous sessions I dictated shear plane is the plane which carries highest shear. Shear plane is the shear plane carries highest shear, like that I dictated. So whichever plane carries highest shear, that plane is called shear plane, and this theta should be theta S. Here theta S means angle of shear plane, right? So this is another important formula. Please copy these 3 steps. I hope you copied. Alright. So just we derived a formula to find angle of shear planes. Angle of shear plane. Okay. So here I can write like this, tan 2 theta S could be also written as tan 180 plus 2 theta S. Either 2 theta S value or 180 plus 2 theta S value, tan value doesn't change. You may take 2 theta S or 180 plus 2 theta S, tan value doesn't change. So I can write like this. Please write this, man. Tan 2 theta S is equal to tan 180 plus 2 theta S. Tan 2 theta S is equal to tan 180 plus 2 theta S. What this equation is saying? There are 2 angles which may satisfy this equation. There are 2 angles which may satisfy this equation. One is 2 theta S, other is 180 plus 2 theta S, right? So what is phase difference between 2 theta S and 180 plus 2 theta S? What is phase difference between 2 theta S, 180 plus 2 theta S? 180 degrees. For 2 theta S, phase difference is 180. What is phase difference for theta S? 90 degrees. For 2 theta S, 180. For theta S, 90. That means what? There are 2 shear planes which are separated by 90 degrees, right? Now write this sentence. The above expression shows the above expression shows there are two shear planes. The above expression shows there are two shear planes. There are two shear planes which are separated by, there are two shear planes which are separated by 90 degrees, which are separated by 90 degrees. In bracket, shear planes are orthogonal. Shear planes are orthogonal. So you may write like that. Shear planes are orthogonal. Orthogonal means mutually perpendicular. One more point let us try to discuss here. Okay. We know tan 2 theta p formula. We know tan 2 theta as formula also, man, right? Try to guess what is tan 2 theta p into tan 2 theta s. If you multiply tan 2 theta p and tan 2 theta s, you will easily get -1. You verify, man, right? Tan 2 theta s is negative reciprocal of tan 2 theta p. Okay? So this question came in GATE exam. Tan 2 theta p into tan 2 theta s is equal to dash, -1. It is one of the popular questions. Now, tan 2 theta p is equal to, I bring tan 2 theta s to other side. So, -1 by tan 2 theta s, right? -1 by tan 2 theta s means minus cot 2 theta s. So, tan 2 theta p always equal to minus cot 2 theta s. Tan 2 theta p is always equal to minus cot 2 theta s. Now, a small thing here. What is tan 90 plus 2 theta? Everybody may know. Tan 90 plus 2 theta is equal to minus cot 2 theta. Tan 90 plus 2 theta, okay, of course I have to put 90 degrees, right? Tan 90 plus 2 theta is minus cot 2 theta. So what is your understanding? When you add 90 degrees to tan, when you add 90 degrees to tan, tan becomes minus cot. When you add 90 degrees to tan, tan becomes minus cot. That means what? What is the meaning? What is phase difference between 2 theta p and 2 theta s? For getting minus cot, I have to add 90 here. That means phase difference between 2 theta p and 2 theta s is 90 degrees. If phase difference between 2 theta p and 2 theta s is 90 degrees, what is phase difference between theta p and theta s? 45 degrees. For 2 theta, 90 degrees. For 1 theta, 45 degrees. So please copy these 3 steps and I will dictate one sentence. Copy these 3 steps, then I will dictate one sentence. Now you may write, the above expression shows the angle between a principal plane, the angle between a principal plane and corresponding shear plane is, the angle between a principal plane and corresponding shear plane is 45 degrees. The angle between a principal plane and corresponding shear plane is 45 degrees. So what is our understanding? Angle between any two principal planes is 90. The angle between any two shear planes is also 90. Angle between a principal plane and shear plane is 45 degrees. These things we learnt. Now similar to principal plane triangle, here I am going to draw shear plane triangle. Now this angle is 2 theta s. We just derived tan 2 theta s is equal to minus of sigma x minus sigma y by 2 by tau xy like that. Opposite side is minus of sigma x minus sigma y by 2. Adjacent side is tau xy, and obviously hypotenuse will be half into square root of sigma x minus sigma y whole square plus 4 tau square xy. Please copy this triangle. This is shear plane triangle. Here theta s is angle of shear planes. Angle of shear planes. Angle of shear planes. From this triangle we are going to derive the maximum in plane shear stress. Maximum in plane shear stress. Right. By putting theta s in place of theta, what is the meaning of this, man, right? I am replacing theta with theta s. That means I am trying to find shear on shear plane. I am trying to find shear on shear plane. So shear stress on shear plane is nothing but maximum in plane shear tau 1. Here tau 1 means maximum in plane shear stress. Right. You know what is sin 2 theta s? What is sin 2 theta s? Opposite side by hypotenuse. What is cos 2 theta s? Adjacent side by hypotenuse. In place of sin 2 theta s, cos 2 theta s, you have to put these values. If you put these values, the solution will be like this. Tau 1 will be equal to half into square root of sigma x minus sigma y whole square plus 4 tau square xy. The maximum in plane shear stress comes out as half into square root of sigma x minus sigma y whole square plus 4 tau square xy. Right? This is also equal to sigma 1 minus sigma 2 by 2. You can verify also, man, right? We know sigma 1 formula, we know sigma 2 formula. If you use this relation, if you simplify this, again you will get back this. So, to find maximum in plane shear stress, either you may use this formula or this formula, man. Okay? Please copy. So, please copy these 3 steps. We just derived a formula for maximum in plane shear. Okay? Either this formula you may use, either this formula you can use. Any of these 2 formula you can use. Right. So we just derived maximum in plane shear stress tau 1 is equal to sigma 1 minus sigma 2 by 2. Obviously here when you put theta s you will get plus. When you put 90 plus theta s, why 90 plus theta s? Angle between any two shear planes is 90 degrees. If you want to find shear on second shear plane, replace theta s with 90 plus theta s. In that case, you will get minus here. So, maximum inclined shear stress will be either plus or minus. In previous session, we did some problems, man. In those problems also, you might have realized two mutually perpendicular planes are carrying same numerical value of shear, but nature is opposite. So, here it is again proved. So, maximum inclined shear stress is equal to sigma 1 minus sigma 2 by 2. Similarly, if you extend this concept to 3D, tau 2 will be equal to sigma 2 minus sigma 3 by 2, and tau 3 is equal to mod of sigma 3 minus sigma 1 by 2. Please copy this very important formula. Tau 1 is maximum in plane shear stress. These two are referred as tau 2, tau 3 are referred as outplane shear stresses. Outplane shear stresses. Outplane shear stresses. So please copy these three. Now write these important sentences. Clearly write. Maximum inclined shear stress is equal to maximum inclined shear stress is equal to so these points are very important. Maximum in plane shear stress is equal to tau 1. This is equal to mod of sigma 1 minus sigma 2 by 2. Second, maximum outplane shear stress. Maximum outplane shear stress is equal to maximum of tau 2 and tau 3. Maximum of tau 2 and tau 3 is referred as maximum outplane shear stress. And what is maximum shear? So maximum shear stress is equal to maximum of tau 1 comma tau 2 and tau 3. You know, in many textbooks they may mention maximum shear is always tau 1. Always tau 1 will not be maximum shear. Sometimes tau 1 is maximum shear, sometimes tau 2, sometimes tau 3. Maximum out of all these three, tau 1, tau 2, tau 3 is maximum shear. Be careful, man. So please copy these important points. Maximum in plane shear stress is this much. Maximum outplane shear stress is maximum of tau 2 and tau 3. And maximum shear stress in structure is equal to maximum of all these three. Sometimes this tau 1, tau 2, tau 3 are referred as principal shear stresses. Principal shear stresses. Please copy all these three. So in this session, we made some derivations. In coming session, we are going to do some numericals on this formula. Coming session is very, very important. Usually a gate problem will come from next session. So be careful, be ready. Until next session, have a nice day. Thank you very much. But copy these three important points.